commercial airliner and take it wherever you need to go. So it's really great from that standpoint. And just to underscore what Chip's saying, the ground station consists of the antenna and a transmit and receive radio and a laptop. That's it.
We have one question from social media, and then we'll take the next question in the room.
Yeah, this question comes from Twitter, and it asks, could you tell us about any civilian or emergency uses for response to national disasters?
First of all, one of the key roles that the military has today is in humanitarian assistance. When there's a hurricane disaster, for example, in the Caribbean, the United States military would be called to help and assist in that. Oftentimes, communications and imagery information are lacking in those kind of situations. This could provide tremendous capability for that. It certainly could be available for other government agencies, including civil agencies like NASA. So it has multiple applications potentially.
And we have another question in the room.
Hey, Lisa Gonzalez with Vice. I had a similar question, but once you have this information and this intel and these images, say of a natural disaster, what are you looking for? How does that information help you, help the Army, help anyone make change or do something good?
One aspect would be if you had an objective system, Kestrel Eye, and had a constellation, then you can monitor the situation and provide changes to the people trying to address it more rapidly.
Right. I mean, you've probably heard of these commercial applications for imagery where they'll monitor a parking lot in a commercial company and use the progression of the parking lot over a period of days, months, and even years to determine is that business growing, is it shrinking? So there's lots of applications like that, but just from a military standpoint, certainly trying to understand what the condition is in an area where the Army might be operating and be able to know frequently. The key really is having rapid refresh of the information so that it's not stale.
Any other questions in the room? All right, thank you, gentlemen.
Thank you.
And last but certainly not least, we have a group here today to talk to us from the Boy Scouts of America. We have Elliot Lee, who is a scout with Troop 209, Andrew Frank, scout with Troop 209, and Norman McFarland, the team leader, also with the Boy Scouts of America. And Norman McFarland, the team leader, also with the Boy Scouts of America.
Hello, my name is Elliot Lee, and first slide, please. I'm going to be talking to you about the experiment, and I'm going to introduce you into what we're about to do. Oh, can we have the first slide? Yeah. So our experiment is we're going to use an organism and a known cancer-causing substance, and we're going to use that to measure the time and mutation rate on the microgravity versus gravity on Earth. This could be actually a huge impact on human tissue growth / cancer research. The Ames test is originally used with an organism and a suspected cancer-causing substance, and but we use the direct opposite of that, and we use a known cancer-causing substance and an organism to measure the rate between Earth's gravity and space gravity. Next slide, please. So as you can see, we have different concentrations, and each concentration has different mutation rates. Also, some of the Ames test, it could originally be used, and some of the concentrations that it uses is 4 NQO